These are spectacular space discoveries that completely leave us astonished. Today, we are going to show you the incredible extents that the structures of the universe can take. Are you ready to discover colossal structures and objects that defy your creative mind and textual style? From the powerful sun to an infinitesimal grain of dust, from the massive omnivores of the world to distant giants, passing through a giant that is imperceptible and suspected to be a parallel universe. After today's video, your view of the night sky will never be the same. The largest structure in the universe, the Hercules Corona Borealis Great Wall. This is the largest and most massive structure the observable universe has to offer. The term observable suggests that, from our earthly perspective, it is not conceivable to observe the universe in its entirety. Given that the universe is structured homogeneously and isotropically, it always presents the same appearance to the observer, regardless of viewpoint or observation route. This results in a spherical space around Earth that delimits our cosmic field of view. Due to the expansion of the universe, and the fact that distances have already been extended by the ongoing expansion, the distance to this limit rises to 46.6 billion light-years. But let's return to the colossal superstructure. It spans an incredible size of 10 billion light-years. By comparison, the extension of the Milky Way in the galactic plane is estimated to be between 170,000 and 200,000 light-years. However, the Hercules Corona Borealis Great Wall comes with a significant limitation. We cannot assert with absolute certainty that it truly exists. Before definitive proof of its existence is provided, astronomers refer to the unusually high number of gamma-ray bursts that were recorded in 2013 near the Hercules and Corona Borealis clusters. It is likely that these are massive collections of supergalaxies, forming what is called a fiber. However, one thing is certain. If this cosmic giant, located about 10 billion light-years away from Earth, really exists, we would not only be enriched by a sensational and revolutionary discovery, but also by a cosmic mystery that shakes our usual models to their foundations. Specifically, the galactic giant should not even exist according to our cosmological development hypotheses. The structures that existed 3.8 billion years after the Big Bang should have a maximum size of 1.2 billion light-years. If the Hercules Corona Borealis Great Wall turns out to be real, we would need to completely revise our models of matter distribution from that time. The largest planet in our solar system, Jupiter. No other planet comes close to the impressive aspects of Jupiter. This mysterious gas giant has a diameter of nearly 140,000 kilometers. In theory, Earth could fit more than 1,300 times inside this planetary giant. However, the imposing size of Jupiter is nothing compared to the size of the exoplanet HD 1546b, located about 360 light-years away from our home planet. This distant world exceeds Jupiter's mass by 752 times. Moreover, this planet is surrounded by a circumplanetary disk, which means it continues to accumulate mass. Identified in 2014 as one of the few exoplanets to be directly observed, this planetary mastodon takes about 250 years to orbit its star. The largest star, Uy-Scuti. When we look at representations of the giant star Uy-Scuti, we have to take a second look. Yes, this barely larger than a dust grain is our Sun. What represents the absolute size and mass of our system seems eerily insignificant in comparison to other structures in the universe. Located about 5,000 light-years away in the constellation Scutum, Uy-Scuti's radius is 1,700 times that of our Sun and could theoretically fit nearly 5 billion suns inside. As a variable star, it experiences fluctuations in luminosity over relatively short periods. Uy-Scuti is in the last stage of its evolution, having already left the main sequence several million years ago. However, Uy-Scuti must concede defeat to another star in terms of mass and luminosity. These titles currently belong to our 136A1, a Wolf-Rayet star about 1 million years old, with a radius of 35 times that of the Sun and a mass 265 times that of the Sun. Furthermore, this member of the R136 Superstar Association shines 10 million times brighter than our Sun. In terms of temperature, our Sun also admits defeat, with an average surface temperature of 5,500 degrees Celsius, compared to our 136A1's temperature, which exceeds 40,000 degrees Celsius. The largest black hole, TON 618. In general, Nothing that crosses the event horizon of a black hole can escape again, not matter, radiation, or information. These cosmic omnivores literally destroy everything and keep devouring the world. These gravity monsters can easily exceed the mass of the Sun by a factor of millions, even billions. However, we still do not fully understand the details of the formation of supermassive black holes. One thing is certain, though: they are not the ruthless machines they are often depicted as. To fall into one of these entities, an object must approach dangerously close to its event horizon. Outside this death zone, supermassive black holes behave like ordinary masses that can orbit in stable trajectories without issue. It is now considered certain that supermassive black holes reside at the center of nearly all galaxies and play a fundamental role in their evolution. And yet, despite all this, the sheer scale of the black hole TON 618 fills us with an overwhelming feeling of insignificance. With an estimated mass between 66 and 70 billion solar masses, this object, located in the constellation Canes Venatici, is the most massive known black hole of its kind. It lies at the heart of a distant quasar, a very active galactic nucleus with a luminosity 140 billion times greater than our Sun. This quasar is one of the brightest objects in the observable universe. So bright, in fact, that we cannot even observe the galaxy associated with it from Earth. A parallel universe. If we follow the usual cosmological hypotheses, the movements of galaxy clusters should be randomly distributed in all directions. However, this is not the case. Scientists reached this puzzling conclusion a few years ago when they evaluated data collected by the WMAP satellite. NASA specialists realized that galaxy clusters displayed an astonishingly uniform movement pattern. It seemed as though the galaxy clusters had fallen under the powerful influence of an unknown and gigantic gravitational force. As a result, astronomers identified 1,400 galaxy clusters involved in this mysterious galaxy flow. In light of this galactic mystery, the lead expert of the NASA research team, Alexander Kalinsky, arrived at a revolutionary conclusion. Starting from the premise that the numerous measurements couldn't be a statistical coincidence, he declared, "We don't have enough information to know what it is or to reduce it. We can only state with certainty that the world somewhere in the middle is very different from what we see locally. We don't know if it's a different universe or a different space-time structure." What truly triggered this phenomenon, now called the Solemn River, remains a mystery. Fundamentally, no one can accurately describe how the universe appears beyond our natural line of sight. While some researchers assume that the structure of the universe in that region resembles the zones we know, others suspect that objects and structures are hidden in the hidden universe, beyond our creative imagination. The most stupendous star cradle, the Tarantula Nebula, can claim two titles. It is both the largest known nebula and the most active star-forming region in our galactic neighborhood. With a diameter of 2,000 light-years, this structure, also known as TR Doradus, is located approximately 163,000 light-years from our planet. The nebula owes its unique luminosity to a structure we have briefly mentioned before, the supermassive star cluster R136. Contrary to the official designation, we're not dealing with a deadly venomous spider but a stellar nursery that shows us the natural beauty of the universe with its breathtaking orbits of gas and dust. The greatest void, however, is in some ways even more astonishing. Amidst the thousands of objects that fall toward us from the sky on starry nights, we must not forget that certain regions of the universe are also characterized by vast emptiness. For example, in the Hydra constellation, specialists have detected a vast region that is strangely much colder than its surrounding areas. One of the possible explanations is that the so-called cold spot in the cosmic microwave background, CMB, is actually a supervoid, a massive emptiness extending over an area of 1.8 billion light-years. The largest galaxy, excluding the Milky Way's halo, is estimated to have a diameter of 105,000 light-years. While our galactic neighborhood doesn't particularly stand out from other spiral systems, IC 1100 shows us what the arrangements of stars, planets, and other objects influenced by gravity can truly look like. Located 1 billion light-years away in the Virgo constellation, IC 1100 spans an incredible 5.5 million light-years. If IC 1100 were placed at the location of the Milky Way, it would effortlessly come closer to our galactic neighbor Andromeda. Now, we're eager to know your opinion. Which cosmic structure amazed you the most with its extreme features? Feel free to share your thoughts, ideas, and reactions to today's video in the comments below. Don't forget to give us a thumbs up and subscribe to stay informed. Thank you for watching, take care, and see you next time.